Students, in this part of the video, we are going to learn about the magnification of the spherical surfaces. Magnification of spherical surfaces. You know that spherical surfaces can be classified into two types. They are the concave and as well as the convex. Here, we already learned that if you use a concave mirror, then the things appears to be bigger in, where if you use the convex, things appear to be smaller. And we got few examples regarding, like concave mirrors are used by dentists. They have to study the position of the teeth. That's why they have to see a enlarged image, that means magnified one. In the same way, convex mirrors are used in rear view mirrors of the vehicles. That means they need a larger view of the field, and maybe the things appear to be smaller, but they get a larger view of the field. Then they can identify which vehicle is behind them and which is near and far. Let's say the magnification of a concave mirror. Before that, you have to understand what is the magnification is. Magnification can be stated like this. It is the ratio of the image distance to object distance, and as well as the ratio of height of the image to the height of the object. Height of the image to the height of the object. Let's see what happens. Let's take a concave mirror, a concave surface, and I am silvering this. You know that silver behaves like a opaque, and this one will be the reflecting. The inner bulged surface behaves like the reflecting surface, and the outer is the opaque. Then we have to locate a point, the center, we call it as the P, and try a line. It is the principal axis, as you know. It is the principal axis. And here we are taking a extended object. In previous sessions, I explained you what are the extended objects. A such extended object, name it as AB or OJ, you can, object OJ, and take a line. It means a ray is proceeding from the head of the extended object in this way. It comes an incident on. If you recall back your memories of the loss of reflection, what happens here? Here we have to drop a normal. It is, and this normal always passes to the center of curvature, as it is anguli, and the same angle we will get for the reflected ray, and the ray passes in this way. And you know that it is the focus. What is the focus? It is a point on principal axis where the light rays will meet after reflection will end. And one ray, it make to pass through the focus, and we are taking one more ray. Here, watch this diagram carefully. When you are need to draw a ray diagram of the light ray, better to take one ray from the head of the object and make one ray to pass through the pole. Here it gets reflected again, and here the point where this ray, which is coming from the focus and as well as the pole, will intersect, and we will get an image here. It is easy to draw ray diagrams by using a V here and a ray which is passing from the head of the object. Here it is the AB, and if you watch it carefully, the head is shown upside down, and I am calling it as A dash, and it is B dash. Means what? Here the image is inverted one. And if you watch it closely, you will find two triangles here. Let's see. We have one triangle. This one. Okay. And we have one more. See this? This one. If you watch them closely, they are similar triangles. Their corresponding side ratios are same. You know that? And we are writing the ratios. You can write AB upon A dash B dash is equal to, it is PB by PB dash is a ratio. Then say from P to B, it is the object distance. We can write PB is measured as object distance from here to here, and say P to B dash, here the image is formed. We can write it as PB dash is equal to V. Okay. And also AB is the height of the object. I am writing AB, height of the object, as HO. Okay. And this is the image. A dash B dash is equal to height of the image. The distance from the pole to the object is known as object distance. That's why I took it as the U. And the distance from the pole to the image is the image distance, it is V. And see, AB is the height of the object and A dash B dash is the height of the image. And we have the four values. We got the U, V, HO and HI. We have to substitute all these values here. Before substituting the values, we have to go with the sign convention. In the previous class, I explained you sign convention. About sign convention, I said all the distances must be measured from the pole. The distances which are measured along the incident rays should be taken as the positive. Against the incident rays should be taken as negative. Up the plane it is positive, down the principal plane it is negative. Then we can write U is equal to minus U, since we measured opposite to the direction of the incident ray. And V is also, see this image is also formed here, and V is equal to minus V, it's also negative. I told you why it is. And HO, height of the object, is a plus HO because it is up the principal plane. And this one HI is equal to down the principal plane, it is minus HI, negative. Okay, now we are substituting all these values in this relation. That is AB we got HO, height of the object by height of the image. I put the negative sign here. And PB is U minus U upon minus V. Minus minus get cancelled, and we get U by V is equal to HO by minus HI, or it can be written as V by U is equal to HI by HO minus. As you learn that image height to object height is known as magnification. That is magnification small m is equal to minus V by U. Here you have to be cautious. What this negative sign indicating? When the image is formed in front of the concave mirror, the negative sign indicating that it is the inverted image, is image characteristic. It is negative sign is indicating that it is the inverted image. Don't think it is the virtual. Generally we take the negative sign for the virtual, but here it's not. It indicates that the image is inverted. And watch the characteristics. It is a real image. can be caught on the screen. The second one, what I said, it is the inverted, okay, but it's not enlarged. The magnification m is equal to minus v by u. And this magnification can be had with the mirror equation with respect to u and v also. Let's see. Magnification in terms of u and f. As you know that 1 by u plus 1 by v is equal to 1 by f. Already we did. And I am multiplying with u. And what I am getting? U by u plus u by v is equal to u by f. Okay? And also it can be written as 1. Here I am cancelling these two. 1 plus u by v is equal to u by f. Okay? Or minus u by v is equal to 1 minus u by f, or f minus u by f minus v by u. You can write it is minus v by u is equal to f by f minus u, where minus v by u is magnification. It's the magnification in terms of focal length of the mirror and as well as the object distance. I hope you understood. Magnification, already I told you, linear magnification is the ratio of image distance to object distance. Already we derived an expression for magnification in case of the concave mirror. Now we are going to derive the expression for the convex mirror. It looks somewhat complicated when you saw the diagram, but it's very easy. What's this? Let's take a convex surface, inner surface. It is the opaque and it's the reflecting surface. We are doing the usual geometry. We are locating a point P. Point P is the principal axis. We are extending this in this way. Okay, it is the principal axis. Now take a object. Same what we did before we are doing. So it is the object, and take a light ray from the head of the object. It is paraxial, means parallel to the principal axis, and it moves on. Okay, and it hits the surface where we have to drop a normal. This normal usually passes through the center of curvature. Okay, it is passing. It is a C, and this ray get reflected in this way. It has been reflected. If I extend this ray backwards, it will intersect a point which is known as the focus. Getting me? And also take a light ray. In previous topic I told you better to make a V here, and it get reflected in this way, and extend it back. These two rays, which one is going through the focus and which is reflected from the pole, met at a particular point where we will get the image. I am calling the object as AB and image as A dash, B dash, and usual things. This is the object distance U, and it is the image distance V, it is the height of the object, and here it is the height of the image. Okay, if you watch it closely, we have two triangles, PAB and as well as the PA-B, PAB and PA-B are similar triangles, and you know that their corresponding side ratios are equal. The two triangles are similar, their corresponding side ratios are equal, and we are writing the same thing, that is AB by A dash B dash is equal to PB by PB dash. Okay, we are writing the values of AB. AB is equal to height of the object, A dash B dash is equal to height of the image. Okay, PB object distance and PB dash is equal to image distance. Now we have to apply the sign convention. Here height of the object HO is plus HO since it is up the plane. HI is equal to same, it's also HI only plus, and the third U is negative because we measure the distance in this way, and V is plus V because we are measuring the distance along the direction of the incident rays. We are substituting all these values in this relation. See, we have to substitute in AB by A dash B dash upon PB by PB dash. AB, okay, is equal to HO, and we got it as a positive, and HI is also positive. PB, this one, it is negative by positive. In other words, we can write minus V by U is equal to HO by HI, and HO by HI is the magnification. We got M is equal to minus V by U. Okay, the same relation we got what we get before. Here you have to think about the negative sign. Here negative sign indicating that the image is virtual. See, it is formed behind the mirror, so it is negative. You have to remember that. When it is a convex, the negative sign indicates the virtual nature. If it is concave, it's a convex, and you have to take it is the inverted one, and we have to find out the magnification in terms of what, F and V. Already we did. As you know that 1 by U plus 1 by V is equal to 1 by F. I am multiplying with V by U. V by U plus V upon V is equal to V upon F. V by U plus 1 is equal to V by F, and minus V by U, I am bringing it here, is equal to 1 minus V by F. In other words, F minus V by F. Minus V by U is magnification. Magnification is equal to F minus V by F. Okay, I hope you understood the magnification of by concave and as well as the convex. If you like the video, forward to your friends, and don't forget to subscribe it. Thank you for watching the video.